Hello and welcome to TidyX episode 116. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes. You can find me on Twitter at @Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick.
All right. So, this week's episode of TidyX, we are going to be wrapping up S4. So the last several episodes, we've talked about like how do you create S4 objects, how do you work with them. Then we went into a little bit of a demo, going how would we approach doing building a tournament simulator in S4 objects. We've done that with S3 objects, and now we're going to wrap that up in this episode. So if you remember, last episode we went through and were able to simulate a game, and that's as far as we got. But we all know a tournament is more than just one game. It has multiple games. That's why it's a tournament. So we are going to build out how we simulate a round of a tournament, then a full tournament, and then simulate a series of tournaments to then give us an idea of who we should count on winning overall. And we have some fun little nuggets along the way. So we'll try to go through this quickly, at least this first part here, because this is what we did in episode 115. So we create a class for our team objects, a constructor for them. So let me just quickly run them. We have a bunch of teams. We go all through this in detail in episode 115. So if you want the details, go there.
Mm-hmm.
We create a bunch of teams. We create a function to predict the team performance using a normal distribution. So we can run that. Hey, what do you know? Bunch of team performances. We create a class to hold the results of a simulated game for us and create methods for showing the results, getting us the team winner, getting the win percentage of the winner, simulating a simple function to simulate a game where now we can run and simulate a game 10,000 times between two different teams and give us the win probability of which team. And they're random, so the values will change ever so slightly. So you can see with Riverhawk and Fauxhawks, this simulation said 59% of the time we should expect the Fauxhawks to win. This simulation said 58% of the time we should expect them to win because it's a random process. And then we had a fun little piece here where you could it'll grab two random teams and run them against each other. Run a simulated game for us and tell us what the probability of running. So great, that is episode 115 in a very, very fast nutshell. Now we're going to get into episode 116. So the first thing I'm going to do is I'm going to change how run sim game works. Before that was just a function that we pass two teams and the number of simulations we'd like to be using, but that's not very expandable or changeable because we're going to be using run sim game a few times. So I'm going to be using the generics that we can use in S4. So I'm going to set a generic for run sim game. And this is how you tell I want to create a generic for run sim game. Now, this is what says I'm going to create a method for run sim game when you pass a team object to it. So this would be like our normal situation where we pass the two teams to it. If keen eyes will see, this is essentially identical to the previous function that we wrote. And that's on purpose. The only difference is as opposed to team one, we have object. And that's just an artifact of how we set up our generic here for an S4 object. But functionally, it's the same, if you can trust me. But also, I will demonstrate that here. Line 182, you'll see that this looks identical to what we had before. And as you can see, it runs and gives us the same sort of results as we were getting before. So we know it is at least doing something similar. So cool. So now we're able to, we've created a generic that allows us to run simulated games in a little bit nicer format. And the reason we do that is because of some future stuff we're about to get into. So if we wanted to simulate a 4-team tournament, we can do that right now with the functions we've defined. We can run the simulated game for the Jayhawks and Chickenhawks, run a simulated game for the Riverhawk and the Fauxhawks, I wrap them in a show. That way it prints out a nice, like, here's the victor. Here's what we got. And then we use the get winner function to pull out the winner of this game and the winner of this game and throw it into another run sim game. So we can do that, and we see the Jayhawks, Chicken Hawks, River Hawks, Faux Hawks, and then the winners of those two games, which are the Jayhawks and the Faux Hawks, play each other, and the Faux Hawks win this 4-team tournament, and they won 50% of the time. And you can run that, and what do you know? It does the thing, and it's great. It's wonderful. But this is kind of obnoxious to look at and run. It's not super easy to tell what's going on. What's going on? Who's the victor? So what we're going to do instead is we're going to create a new class called matchup. And all matchup is going to do is it's going to hold the two different teams that we're wanting to play. So we can create representations of here's the different matchups that we're wanting to be running. We're then going to create a function called matchup that's going to just be a wrapper around it to make it easier to create the matchup object as opposed to having to do new matchup team 1 team 2. It's just matchup team and you pass team 1 team 2. It's not like rocket science or anything too crazy. But the nice thing is that we can then create, because we have this class matchup, we can create a method for run sim game where we pass in the matchup object and the same sort of information we do for the run sim game, and then we can kind of under the hood then call the first version of the run sim game, or the first method that we created for run sim game for the teams. And so we're just kind of abstracting it a little bit to make it a little bit nicer to work with. But then ba-boom, ba-boom, these are the same. These behave very similarly, and we want that because in this situation, this kind of seems like a little bit of extra work, but it is going to save us work in future steps. So everything is like thinking about the future. Like it's a little bit more work now, it's a little bit more work now, but it's going to save us effort in code in the next step. Next, we're going to simulate a tournament round, which as we know is multiple games. And so this is why the matchup object is useful. Is we're going to accept a list of different matchups that we're expecting to run. We're going to simulate each of those games however many times. We're going to loop over each of the matchups. We're going to simulate that game, but as you can see, this code is super easy. We just have that matchup object and the number of simulations we want to run. We're going to print out the results of that simulated game and pass it into this round winner object here, which is now a list of the different results of the games. And we're going to invisibly print it because we don't want to print out the list because we're already showing the game results here. So now we can build that up. And so now it makes it really easy to do a single round of the matchups between the Jayhawks, Chicken Hawks, and River Hawks and Faux Hawks. Run that. And hey, what do you know? The Jayhawks win 60% of their games. The Faux Hawks win 58% of their games. So once again, abstract up another level. How do we run a tournament? Same sort of idea. But as opposed to passing a list of matchups, we're going to use dot notation just because I like being weird. And it makes it easier so that way I don't have to like wrap it in a list and have that predefined. I mean, technically we could have done just match up list here, and then we'd be happy and snappy, but I am not doing that. So I'm going to use triple dot notation there, and the reason I do that is because then I can do something like this and pass just as many matchups as I want to into run tournament. It makes it easier for me to do that. We're going to convert that into a list in here. We are going to create an object called round list, and what that's going to do, it's going to hold the results of each round for us. So if we want to inspect the results of our run tournament, we can look for, like, if we notice that a team's winning more than we'd expect them to, or if our simulation is giving us strange results, which was actually happening when Patrick and I were writing this code, we were able to go back and inspect the results of each round and go, why is it doing this? We actually found that we were setting a seed improperly, and so it wasn't updating randomly like we were expecting it to, it was always using the same seed, which means that our simulations were always the same, which means they weren't really simulations, right?
Mm-hmm.
We were like, let's simulate this 1,000 times, but we're going to use the same seed. That's not random. That's not going to give us the randomness that we're
Yeah.
looking for.
Yeah.
Um, so then this is the same logic that we used for the S3 tournament. So while we still have matchups to run, we're going to loop over it. We're going to run the round of tournament. The That sounded strange English wise to me, but we're going to run a round of that tournament. There we go. Using the matchup list and the number of simulations that we want. We're going to store the results here. We're going to drop that into our list containing the results for each round. We're going to pull out the winning team. And then if we have more than one team, we're going to reconstruct the matchup list object to share out. If we don't have more than one round winner, which means we're at the end of the tournament, we're going to break out of the loop. Okay. Then we're going to nicely print out, hey, this team won, congratulations. And then we're going to invisibly return the details of our tournament. So who won each round of the tournaments, and it's nice to kind of structure this way, because then the first entry in the list is the first round of the tournament, the second round of the tournament is the second entry in the list, and so it's kind of, I thought that was kind of nice to deal with that. And so now what we can do is we have this full tournament. We can run the different matchups, and we're of course setting the first set of matchups. We're assuming this tournament is a single elimination, no buys. Everybody has to play to the very end. You don't get benefited for being the best team. And so we can simulate that. And as we can see, we say the Hawkeyes won this game. So now we can
Run the tournament.
Hmm?
Hawkeyes won the tournament, not the
Yes.
game.
Yes.
Yeah.
The tournament.
Do it. Yeah.
And so, but now we can look at round 3, which is the final round. We can look at round 1, and this is those 4 games that we looked at there. So now we can kind of inspect them and see if there is anything funky going on with that, which is kind of a fun thing to do. But what if you want to visualize how this, like, the tournament went? So you can use the library ggplot, and because we stored the results of the games in predicted results, we can look at like the simulation of the championship game that we had. So we can pull that out here, and this is, if we were to play the game 10,000 times, these are the different scores we'd get. We can also throw it into ggplot, where we say take data. We go, okay, here's our predicted results. Create a histogram for team 1. Create a histogram for team 2. Well, let's not move anything around. Team 2. Color team 1's simulations green and team 2 simulations blue. And then add a nice little title going, okay, team 1 is this one and it's green, and team 2 is this one and it's blue. And so we can run that, and we can see, lo and behold, ba-da-da-da, this is the championship game simulated 10,000 times between the faux Hawks in green and the Hawkeyes in blue. Patrick, do you want to help provide
There's only one problem with what we did. The only problem with everything that we did is we're simulating the games. Yeah. So we're simulating game matchups, and then we're saying, okay, if we wanted to predict the outcome of this game, we simulate this matchup and we say we have a higher probability of this team winning, so they should move on. And then we do it again, and we say there's a higher probability of winning so this team should move on until there's no teams left. Which is cool. It's simulating a game, but it's not simulating a tournament exactly, because in reality, the tournament, each team plays once, somebody moves on, next 2 teams play again one time, somebody moves on until there's an eventual winner. So what we really want to do is be able to engineer this so that instead of only looking at games, we can actually simulate the tournament itself and get the probability of any one team moving through the tournament to being the last team left, the last man standing, right?
Exactly. And so that's where we write this new function, which we forgot to do for S3. So, like, don't call us out on it. We recognize that we didn't. Well, we do now. But nobody called us on it. So I'm going to give us a pass.
Yeah.
Now we're going to simulate a full tournament. We're saying we're going to simulate this tournament n sims times. And because we've done all this build up, it's actually really easy to write this function to simulate the tournament. We're going to say, okay, we're going to create an object called simWinner that's going to contain just a vector of the names of the teams. We're kind of done with the details. We've already kind of built up our simulations and our tournament simulation, everything up already. So we're fairly confident in everything that it works there. So now we can just do a kind of a dumb for loop. And we can do for I in seq length n sims. So this is saying for I in 1 to n sims,
1,000.
which
Yeah.
default is 1,000. We set it to be 1,000 because it can take a little bit to run. We're going to simulate a tournament, but for the tournament, if you remember in run tournament, n sim represented the number of games to simulate in each, or the number of times to simulate each game. And
Mm-hmm.
for our question, we want to know who's most likely to get to the very end. And so we don't want to play each game more than once. So we're going to set nsim to 1. We're going to run that tournament and capture the results. We know the number of, I guess this is cheating here. We should probably change this, but we know that we're only passing 8 teams, so 4 matchups, and so we know that the tournament will only last 3 rounds. We should probably actually do this to be a length of tournament results. Yeah, let's do that. That feels more robust. So this is saying grab the
So,
last entry of tournament details,
the length of tournament details
or
or
excuse me,
tournament result.
results.
Yeah.
Tournament results. Good catch.
Mm-hmm. Mm-hmm.
Thank you for questioning me on that. Grab the game out of that. Let's get the winner
Mm-hmm.
and put that winner's name in our vector. It's actually pretty simple, right? We thought, like, if we tried to do this from the beginning and just straight up simulate a tournament, the code to do that would be a bit longer than this. And yeah, we have all this extra code around here, but we're able to check at each point, does our game simulation work? Does that make sense? Does our round simulation work? Does that make sense? Does our tournament simulation work? Does that make sense? Now we can simulate all the whole shebang together. And so now we can simulate a tournament between all these folks here. We're only going to run 1,000 simulations, so it's like, I don't know how robust that would be. But
There it is.
now done. And so now we can look at res here, which is results. I was just lazy when I named it. And we can see that there's like Jayhawks, faux hawks, greyhawks are in here. So now we can do a prop table. So we're going to take a table of res. So this will give us the number of times each team shows up. And then we can do a prop table. And that's going to give us the proportion for each of the winners. So basically when we look at this now, let's zoom into this a little bit, is we're saying that it's like 33% chance of the faux hawks, gray hawks, or the jayhawks to win out the entire tournament. The Hawkeyes and the Riverhawks are Cinderella stories.
Well, no, really, the Cinderella stories are the 3 teams that won 0 times, aren't they? Those would be the really Cinderella stories.
That would be.
There's 3 teams that basically in the tournament simulation never won once. So they would be the true the orange Hawks, the hockey talkies, missing
and the
one
Riverhawks. No, the Riverhawks won.
Riverhawks won. The Chicken Hawks.
Chicken Hawks.
Yeah, those are the 3 teams. They'd be the super Cinderella stories because we basically said that they never had a chance to win. They never were simulated to win.
Yeah. Exactly. But what I thought was interesting when we looked at these results is, for example, the Hawkeyes. We said that they were the strongest team, but they had really high variance, and so
Yeah.
they are very unlikely to win. Even the Hockey Talkies, which were ranked second, I mean they also have high variance.
Their variance is larger than their actual performance. So they're yeah, you don't know what you're buying with that team.
But yeah, but like the
The Chicken Hawks
Jayhawks,
are very low. Yeah,
the
exactly.
Greyhawks and the Jayhawks have similar strength, or they have the same strength and SD, so it kind of makes sense for them to be matching up. But the Faux Hawks, they actually predicted to win a little bit less, even though once again their standard deviation. So I guess takeaways, you want a consistent team.
Yeah, consistency is a good thing.
Yeah, but yeah. So this is how you can go and build up using S4 objects this time, and then also our improved. Oh, we need to actually simulate a tournament and simulate it, not just run a tournament.
Mm-hmm.
Go from S4 objects, creating your teams, creating your matchups, kind of debugging as you go, uh, building up the game, building up the rounds, building up the tournament, and then finally simulating that final tournament.
Yeah,
And this,
that's
I think,
awesome.
will conclude our S4 series. If you have any additional questions for us, post them in the area down below on YouTube. You can also, tag us on Twitter or do whatever. And with that, we're going to call it. As always, my name's Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSP Patrick. And you can find both of us on Twitter at tidy_explained. Tidy.explained@gmail.com is where you can send us an email, but most people just go to the YouTube channel, like and subscribe, and drop a comment or question or thoughts below. And if you feel like any of our work has supported your work and you'd like to support us, we do have a Patreon page, and anything that you donate would be greatly appreciated.
Exactly. Thank you all so much, and keep on exploring your world.